In this tutorial, we will be covering two aspects. The first is the clipping abilities of ACE 3D, and secondly, we'll be discussing the anti-area or negative area capabilities that ACE also has. So the first thing I'll do is just load in a set of generic design data. You can just select them all at once. There's multiple files. Let ACE figure out the rest. Okay, and the first thing I will do is go to the advanced section, and it says keep adjacent pads during clipping operations. So what this does is when I do select the clipping area, if there's any pads that intersect in that particular area, the pads will remain. If this is unchecked, those pads will be sliced. All right. As you see here, I've imported in my board. And what I'd like to do now is we're just going to use the clipping to clip out a small section. So the first thing I can do is go clip area and use one of the commands here. So I'm going to select a large area because I'm going to use clipping twice to show some of the features that are available. So the first thing I'll do is we'll go clip and I'll select the points myself. And I'll select quite a wide area. And as you see here, all the pads that touch the clipping area are still remain existent. And this is because for many calculations and simulations, they do require to have the net with the entire amount of metal still available. So what I'll also do is show you how to use clipping directly from here, which is even easier. You just select a square. You just basically choose your area and the clippings automatically perform for you. So now that we've got that out of the way, let's go ahead and show you how to make negative metal. Typically, plain layers will show just thermals. We'll show this again. And it'll show just the thermals are the opposite of what the metal is that you actually do need. The same here will hold true for mask layers, where you have the opposite of where the mask actually will reside. So what you'll do is put all the layers on. We'll go to convert. And as you see, ACE is already detected because there were thermals on those layers that they are negative metal. This is the bottom layer, and that's another metal layer. So those are 4 metal layers. The mask layer also is going to be negative, so we choose negative mask, and this will also be negative mask. Here's a solder paste. We're going to add paste, and then the silk screen. So once we've defined the layer types, now let's go ahead and just sort out the layers correctly. We'll put the silk screen on the very top, and everything with ACE is kept simple. We'll drag and drop. Actually, we'll put this solder paste on the very top, then silk screen. Then we'll do the top mask, top metal, then the ground, power, bottom, mask, drill. Great. Since it's a 4-layer board, we will need 3 dielectrics. So let me go ahead and add the first dielectric. And in this particular tutorial, the thicknesses are not taken into account. These are things that you'll be able to determine when you create your own stack up. However, just for tutorial purposes, I just want to show them being there so you're well aware of how this works. So all you do is you simply drag dielectric 1 in between the top layer and the first ground. And then I'll go ahead and add the next dielectric. Drag that right between the ground and the power. Add another dielectric. And drag that between the power and the bottom layer. So I've got 3 dielectrics, 4 metals, a bunch of negative metal areas that have been defined. So now lastly, I just need to, well not lastly, second to last, I just need to assign the thicknesses of each layer. And these were just being more generically entered. And a nice thing to always remember when using ACE is once you've set this up correctly, go ahead and save your map file. By saving a layer map file, should you need to perform this exact same conversion again, you just simply are able to select the map file and your complete translation is ready for you. You can totally avoid this step. So it looks like I've done that and there. Okay, lastly is we need to set up the Z base, which is where each layer begins 3-dimensionally. So we'll use a feature called Update Z-Base. And from here, I just select OK, and as you see, it's calculated everything for me so that I don't have to worry. So at this point, I'm good. I'll actually go ahead and save my map file. Press save, and then should I need to revisit this again, it's available to me. Press next. Select the location for my outputted step file. Alright, and our step file has been exported. Now let's go ahead and view the results in 3D modeling software. So as you see here, here's all the assemblies that have been created. And let's go ahead and just start off one by one so you can see what's been done to each assembly. So in this case, this was the solder paste. Make sure I figured I was forgetting something. Alright, there's just your paste layer. So pretty much what you would expect. You have your silk layer, same thing. Your solder mask, now this is opposite. So remember, it's just the pads in the Gerber file. What Ace3D has done is it went ahead and created a negative, which means the opposite area. There's the metal for the top layer. Here's your first dielectric. And if you wanted to, let's say, for instance, put the top layer, or part of in any case, the dielectric, got your ground. And see, again, this is where it's been made negative. So these thermals now have been reversed. Your dielectric for the ground. You got the power dielectric. You got the bottom layer for the metal. And you've also got your bottom mask, which again is a negative layer. And here are also the vias used. So for each dielectric, you basically have the vias that pass through there. So it's able to keep track of everything. And pretty much these are the capabilities that are available in Ace3D. Thank you very much.